Okay, guys, we continue and we are looking at the last theorem under the cyclic quad. So I call this one angle in the same segment theorem. So angles from the same segment theorem. So this one is basically very easy. So, but before I can continue here, look at this one. So we normally say T, V, R, M is a cyclic quad. So the reason this one is a cyclic quad, remember according to the definition of the cyclic quad, we say a cyclic quad is a four-sided shape where each of the four corners are touching the circumference. So basically this is a cyclic quad, which is also similar to something like this. So this one is also a cyclic quad because we have 1, 2, 3, 4. So you have four corners touching the circumference. Even here you have 1, 2, 3, 4. So four corners are touching the circumference. So if you look at something like this, there was something that I was using here. I don't know where I lost it. Let me check. Oh, it's fine. Let me show you with this paper. So if you are looking at this paper, this paper. So this paper is a rectangular paper, like this. So sometimes if I can twist this paper, so if I can twist this paper like this, so it's a four-sided shape, so if I can twist this paper, just that it's not visible clearly. So, but you can see these two bow tie parts. Okay, yeah. So meaning, what I'm trying to say is this is a twisted cyclic quad. It's a twisted cyclic quad. So if you are twisting a four-sided cyclic quad or four-sided shape, you'll have something like this. So hence this one is a cyclic quad, but a twisted one. Okay, so hopefully I'm making sense. And then to a simplest thing is to say if the four corners are touching the circumference, which means it is a cyclic quad by definition of a cyclic quad. It is a cyclic quad. And then we are saying, yeah, this is a cyclic quad. So this theorem says this now. If we are looking at MR, this chord, you see this chord MR, this chord MR, this one. This chord MR, this one, subtends angle T on the circumference. At the same time, the same chord also subtends angle V. So we are saying a chord, angles from the same chord are equal. Okay, angles from the same chord are equal. So here I can say angle T is equal to angle T is equal to angle V. But then the reason here that we write, we are not saying angles from the same chord. We are not allowed to write that. But rather you can imagine a line here. So which means now look at this, it's a segment now. So angles from, we normally say angles from the same segment are equal. So we say, the reason we are saying here, we say angles from or angles in. So it's just a matter of English here. It's just a matter of English. So angles from the same, this is A by the way. Angles from the same, this is E. Angles from the same segment are equal. Angles from the same segment are equal. So if you look at this segment, so this angle is from the same segment as this one. So angles from the same segment are equal. So meaning even angle M and angle R are equal. because they are coming from the same segment or from the same arc. So even here I can say angle M is equal to angle R. And then the reason you are saying angles from the same segment. Angles from the same segment, okay, are equal. Yeah, angles from the same segment are equal. So this is what we call a both side theorem now. Okay, this is what I call a both side theorem because it looks like a both side. Okay, and then even here when we are looking at here, you can see from LW, which means from this arc, so from this arc I have angle F subtended and angle Q subtended. So these two angles, which means this one should be equal to this one. So we say angle Q. Remember, you are not allowed to say angles from the same arc. So angle Q, which is this one, is equal to angle F, is equal to angle F. And then the reason we are saying angles from the same segment, angles from, this is M, angles from the same segment, they are equal. Angles from the same segment are equal. So for example, if this one is 40 degrees, for example, and we are saying this one is X, and we say find X. So this one is X, okay? So which means your thing will say, if they say find angle X, you'll say angle X is equal to 40 degrees. So angle X is equal to 40 degrees because they are coming from the same arc. But you are not allowed to write that reason, remember that. So you have this. So you can even do an imaginary segment here. You separate here so that you have that segment. So we say this subtends this angle. At the same time, this subtends the same angle. So which means these two angles are equal. So hence, if this one is 40, this one should be 40. And then the reason we say angles in the same segment or from the same segment, angles in the same segment, are equal. Okay. So angles in the same segment or angles from the same segment. So those who understand, who knows English very well, they can correct me there. Angles in the same segment or angles from the same segment. So here is the same thing. Okay, apologies for that. Apologies for that. So look at this question. This question, you are given angle Y, which is this one. Okay. You are given angle X, which is this one. Okay. So the reason I'm using different lines here is because sometimes these lines, they denote whether the angles are equal or not. So if it's 1 and this one is 2, so it means these angles are not equal. So we are saying this now. So find X and Y, and then obviously you will give a reason. So this angle, which is Y, should be equal to 10. Okay. So the reason angles in the same, angles in the same segment or angles from the same arc, but we are not allowed to write the arc reason. So which means you'll say Y is equal to, so if this one is 10, this one is 10. So you say Y is equal to 10 degrees. And then the reason you say angles from or in the same segment. Angles from the same angles from the same segment are equal. So Y is equal to 10. So here again, we have 50 here, which means this one should also be 50, né? because angles from the same segment. So which means I can say angle X is equal to 50 degrees, and then we write the same reason, which is angles from the same segment, they are equal. So even here also it applies. So hopefully I'm making sense. This theorem is very easy. So which means, in another words, for the cyclic quad, which means a quadrilateral that has 4 corners touching the circumference, you have 3 kinds of theorem, which is opposite angles of a cyclic. The first one, opposite angles of a cyclic quad are supplementary. Second one, exterior angle of a cyclic quad is equal to the opposite interior angle. And then the third one, which is this one, the both side theorem. So there are 3 theorems under the cyclic quad. So let me just do the recap for you a little bit. So we started here to say these two, they always add up to 180. The reason opposite angles of a cyclic quad, which means even these two and this one, 1, 2, they add up to 180. Opposite angles of a cyclic quad are supplementary, or they add up to 180. So this was the first theorem. And then the second theorem, we have this one to say if this angle will be equal to this one will be equal to this one, and exterior angle of a cyclic quad is equal to the opposite interior angle. So that is what we did. And then we went on, and then the last theorem on the cyclic quad is this one, which is the both side theorem. Obviously, this one must also go with the converse as well. So look at the converse. There is it. Look at this one. So what they can do here, they can say this. Look here. They can say a question. Remember, you are not allowed to create your own questions. Mina, I know what questions they are asking for you. We will give you a question, or the exams, people who are setting the exams will give you a question. So we can say here, prove. So the question will say, prove that T, which is T, this for TRWF. TRWF is a cyclic quad. Is a cyclic quad. Is a cyclic quad. So we are saying prove that. So that is the question. So for you to prove that this is a cyclic quad, you can just prove that this angle is equal to this one, or you can use this one. You say this one is equal to this one. So there are 2 ways in this case. I can use these 2 angles, or I can use these 2. It becomes my choice. But because these ones I'm given them, I can just use them straight away. I can say angle R is equal to, which is this one. Angle R is equal to angle W. They are both equal to X. 1, 2. And then, which means if these 2 angles are equal, it means this thing now can fit into its own circle, or it is a cyclic quad. Can you see? So I can say it means now that therefore a TRWF is a cyclic quad. Is a cyclic quad. The reason it's a cyclic quad, it is because, so remember this because, it's because we are using a converse of a theorem that says angles in the same segment, or angles from the same segment. This is S. Angles from the same segment are equal. We are using a converse. Remember, a theorem says if you have a cyclic quad, where is the theorem? The theorem says if you have a cyclic quad, it means these angles are equal. And then the converse says if you don't have a cycle, but you have these 2 angles equal, it means this is a cyclic quad. And then it's a converse now, because this is not inside the circle, but we want to conclude that it can fit into its own circle. In another way, we want to prove that this is a cyclic quad. So if we are proving the theorem without the circle, we always start by writing the word converse first. It's a converse of a theorem that angles from the same segment are equal. The other person can do this if you want to prove this. Can say if this one is 30, by the way. is 30 degrees. Yeah, it's 30 degrees. Let me write 30 degrees here. Yeah, if this one is 30 degrees and then this one, angle T1 is 1/5, which means angle T2 should also be 30. Ne? So you have to start by saying first, angle T2 is equal to 30 degrees, and then you write the reason. You got this using the angles on a straight line. Angles on a straight line. And then now we can say angle T2 is equal to angle. Remember, angle T2 is this one. Angle T2 is equal to angle F. Angle F. Angle T2 is equal to angle F. And then which means therefore TRWF is cyclic. E is a cyclic quad. So E is cyclic, or E is a cyclic quad because it's a converse of a theorem that says angles in the same segment are equal. So it's a converse theorem. So even here on this diagram, still the same thing. If this one is 50, obvious this one is going to be 50 if you are using it a straight line. So you say angle P1 is equal to angle P, which means AB PC is a cyclic quad because it's a converse theorem. So that is what I'm trying to say here. So there are three ways in order to prove that a quadrilateral is a cyclic quad. You can use the converse of the first theorem that says opposite angles of a cyclic quad, when you add them, they give you 180. Or you can use a converse of this one to say, and if the exterior angle of any quadrilaterals is equal to the opposite interior angle, then the quadrilateral is cyclic. Or you can use the converse of a both side theorem. So when a theorem is for you to write the reason that converse, it's a converse, you need to have a theorem but without the cycle on it. So I'm done with the cyclic quad. So now the only thing that will be left is for me to show you, to prove where these theorems are coming from. So I'll do the formal proofs now, where we say, where we show you where these theorems are coming from. So the only theorems we are left with now are the tangent theorems. So we will look at them tomorrow. Thank you.